Model Engineering for Beginners, Part 30, How to Make Your Own Nuts. In the previous episode, Part 29, I showed how to make a couple of bolts using phosphor bronze as a material. In this episode, I need to make a pair of matching nuts to fit the bolts, once again using phosphor bronze. Or to be exact, this is leaded bronze. It's easier to machine than the red type of phosphor bronze. And in almost exactly the same way as I made the two bolts, I've fitted a piece of phosphor bronze bar in my rotary table, and initially I've set the rotary table to 0 degrees. After which, as you see here, I'm machining one of the flats. How far do I move the cross slide? Well, exactly the same as before. If I wanted to make the size of the nut to duplicate a commercial size, the simplest method is to fit a nut in the rotary table and move the cutter, which must not be revolving, towards the nut until it gently touches it. Then just take a note of the number on the hand wheel vernier for the cross slide. And as long as each and every cut are set to the same number on the cross slide, you will end up with a nut the same size as the one you want to copy. On screen at the moment, the rotary table is set to 60 degrees and I'm taking the second cut. And just in case you missed the previous episode, why am I setting the rotary table in 60 degree increments? Here it's set to 120 degrees. And why am I using such a small end mill that's obviously chattering a bit? I'll answer the second question first. I'm using a small end mill just so you can see what I'm doing more clearly in the video. A larger cutter would obscure the work. And why am I using 60 degree increments? That's because a circle is made up of 360 degrees. I need to machine 6 flats on the nut blank, so 360 divided by 6 is 60. And now the rotary table is set to 180 degrees, and this cut is parallel to the first cut that I made at 0 degrees. A rotary table is a very useful accessory to have on your milling machine or even on your drilling machine. This particular small rotary table from RDG Tools can be used vertically like you see here, or if you undo a couple of bolts you can swing it through 90 degrees and use it in a horizontal mode. If you've been watching the video carefully, you will notice my hands come into the shot, and that is always after I've set the position of the table, and all I'm doing is tightening the 2 pinch bolts, which locks the chuck solid so it can't move while I machine the work. Nearly there now, the rotary table is set to 240 degrees. A rotary table is a very useful tool to have in the workshop, and it's great for doing jobs like this. I mean, where could I get a phosphor bronze nut with an internal thread of 1/4 BSF? Possibly nowhere these days. The rotary table is now set to 300 degrees, and this is the final set of cuts. At the beginning of this sequence, I should really have mentioned that when using this type of rotary table that is adjustable through 90 degrees, always cut in the opposite direction to the way the rotary table can swivel, because if you cut in the opposite direction, the table may move and you will lose the setting. When milling, it is always good policy to cut towards the work, so the milling cutter's blades shave away the metal. This is the final cut, and despite the small cutting tool, I now have a phosphor bronze blank big enough to make 2 nuts out of. A friend of mine from the USA sent me a message. His name's Charlie, and he started off the message in a really funny way. This is what he typed. Being retired, here in Alabama, my day starts with a cup of coffee and a quick check of the news to see if my obituary has been posted. It made me smile. One of the things I usually say is, at my age, I've only got death to look forward to. Just one of the things that helps me get through the day. Time for a health and safety notice. It is essential to wear PPE, personal protective equipment, and in this case, eye protection is essential. These chippings are razor sharp. For stage 2 now, it's over to the lathe. And as always, I face across the front of the work first. This makes sure that it is square, and this is immediately followed by drilling with a centre drill, which in turn is followed by using a twist drill to drill a hole down the centre, tapping size for a 1/4 BSF thread. And according to Google, the tapping size drill for a 1/4 BSF thread is 5.3 millimeters or a number 6 drill. Here's the thread in the nut blank. It's a very clean thread because I used some tapping compound. The next part of the job is to part off the nut blank. And I think I should mention that in this video, all of the machining sequences are speeded up. Before proceeding further, it's time to clean up the nut blank. I'm using some wet to dry sandpaper for this job, which is 400 grit. And here is the finished, cleaned up nut blank. Probably a good idea at this stage to check that the nut blank fits onto the bolt, and as you can clearly see, it does. After this, I fitted the nut blank in the 3-jaw chuck and proceeded to part it off. So why am I using a hacksaw? Well, I just wanted to show that you don't automatically need to pick up a parting tool. Maybe you don't have one, but you can still do the job using a hacksaw. In this clip, I'm finishing the front surface of one of the nuts. I'm taking quite a few passes until I get to the mark left by the parting tool. And because the parting tool mark was exactly in the centre of the nut blank, I will end up with 2 nuts that are exactly the same thickness. To create a beveled edge on the front of each nut, I'm using a V-tool. It doesn't really matter because these nuts are not going to be seen at all. The front surfaces of both of the bolts are what are going to be visible. But that's not the point. If a job's worth doing, it's worth doing well. Here I'm performing the same operation on the second nut blank. As before, this part of the process removes the saw cut marks and makes this nut the same thickness as the other one. And also, in exactly the same way, using a V-tool, I'm creating a chamfer on just one edge of the nut. And that's about it. I now have 2 phosphor bronze bolts and 2 phosphor bronze nuts. Both of these parts are for my 4.5-inch scale Showman's engine, and here you can clearly see the application. And that's it for this episode of Model Engineering for Beginners, how to make your own nuts. I'd just like to say, stay safe, stay well, and as always, thanks for watching and I hope you found it useful. Please take the time to visit my Mainsteam Models website and click on the section of the website that says Video Playlists. And by doing that, you can find other videos that you may like to watch. And by using the playlists, you can actually watch the videos back to back, making it unnecessary to comment that the videos are too short.